Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. So, today's topic for the lecture is molality of a solution, and I'm going to solve some numericals along with it. So, let us discuss what is molality of the solution. So, molality. Molality is also one of the concentration term. Is also one of the concentration term used to measure the concentration of solution. Used to measure the concentration of solution. Concentration of solution. But molality is different from is different from molarity. The molarity and molality are the two different terms. Sorry. So molality is also one of the concentration term used to measure the concentration of solution, but molality is different from molarity. So first of all, I'm going to explain you what actually the molality is. Molality can be defined as number of moles of solute. Number of moles of solute dissolved per kilogram of solvent. Per kilogram of solvent. So this was the molality. So molality can be defined as the number of moles of solute that have been dissolved in 1 kilogram of solvent. What was molarity? That was the number of moles of solute dissolved per liter of solution. In molarity, we were having the volume of the solution, but in molality we are having weight of the solvent. So my dears, I'm writing first of all, let's talk about solution first. The same way, I know that solvent plus solute forms me the solution. In my all lectures, I have assumed my solvent to be capital A and my solute to be capital B. My solution found will be AB. So in this topic, my motive is to find the number of moles of solute that have been dissolved per kilogram of this solvent. So that's my topic, that I have to find the number of moles of solute that have been dissolved in 1 kilogram of the solvent. So let's talk about it. First of all, my dear students, molality. Molality is represented by small m. Molarity is represented by capital M, but molality by small m. So it is equal to the number of moles of solute divided by weight of solvent, and very importantly, the weight of solvent must be in the units of kilogram. Now let's talk about the number of moles of solute. In the previous lecture video, I have told you The number of moles of solute is represented by small m. The number of moles are represented by small n. Now I'm talking about solute, so it will be Nb. That stands for number of moles of solute. That will be equal to the given, hold on, let me take it again. Number of moles of solute will be equal to the given weight of solute divided by molecular weight of solute. I have told you that number of moles is represented by small n, and we are talking about solute, so we will have B along it, so it's an Nb. The number of moles of solute will be represented like Nb. Now in the previous lecture I have also told you that given weight is represented by capital W, and that's of solute, so we will write Wb divided by molecular weight of solute. Now molecular weight is represented by capital M along with small b because it's the molecular weight of solute. So first of all we got the number of moles of solute to be Wb divided by Mb. Now let's talk about the weight of solvent. We are having total mass of solution, a term called total mass of solution. Obviously that will be equal to the weight of solvent. Now solvent is A, that's why I have represented A. So Wa stands for the weight of solvent plus the weight of solute. Weight stands for W and solute stands for B, so it's Wb. So Wa can be calculated like mass of whole solution, minus Wb will give you the weight of solvent. Let's talk about molality again. I'm coming back to molality. Now I'm going to put the value of number of moles of solute and the weight of solvent in the main formula. Now molality is small m. It will be equal to the number of moles of solute, so it will be represented by Nb divided by the weight of solvent, so it will be represented as Wa, and importantly Wa must be in the units of kilogram. That's my molality. Now what next was Nb? We have just evaluated. Nb is Wb divided by Mb, so it comes out to be Wb divided by Mb. Now it's a Wa, that's the weight of solvent. A stands for solvent, B stands for solute, and again in kilogram. Now next, Wb divided by Mb into Wa. If your weight of solvent is in grams, then you have to convert this grams to kilograms by dividing weight of solvent by 1000. So finally my formula for molality comes out to be Wb divided by Mb into Wa. I'm just taking this 1000 to the numerator, so it comes out to be into 1000. So that's the formula for molality, and molality is represented by small m. Please keep this thing in mind. Now let's talk about the units of molality. Now let's talk about units of molality. So what was the molality? It was the number of moles of solute per kilogram of solvent. So the unit of molality comes out to be moles per kilogram. So that was the topic about the molality. So what next? I want to tell you all that that molality molality is more better and convenient method of concentration of solution than molarity. Molality is better and more convenient convenient method of measuring concentration of solution than molarity. Now let's talk about that why molality is more convenient method than the molarity. In the previous lecture that was about the molarity, I have made you understand that molarity is inversely proportional to volume, and you all know that when we increase temperature, on increasing temperature, volume expands, volume of solution expands, due to which, first of all, if temperature is increased, then volume will also get increased. Then obviously molarity will decrease. I have given you this whole relation in the previous lecture, that if we increase the temperature of the solution, the volume of the solution expands. Now volume has an inverse proportionality with the molarity. So if the volume increase, let me take it more clear way, just hold on. Now if the volume increase, then obviously molarity will decrease because of inverse proportionality, because of this inverse proportionality. If volume is increased, then molarity will be decreased. But our molality sorry but molality but molality is independent of temperature. Molality is independent of temperature. Why so? That if you will increase the temperature, the volume of the solution will expand, but the weight of solution will remain constant. That is, I'm writing it here, that on increasing temperature, I admit that volume of solution will expand. Volume of solution will expand, but weight of solution, weight of solution, more specifically, weight of solvent and solute will remain constant. Will remain constant. Now, we all know that what's the formula for molality? It is equal to the WB divided by MB into WA. If it's in grams, then you have to multiply it with 1000. Here you can observe that molarity of solution has nothing to do with the volume of the solution. It is independent of the volume of solution. Hence, molarity will not change with increase or decrease of temperature. That is, molality is independent of volume, is independent of volume of solution, So molality will not change. Molality will not change on increase or decrease of temperature. So my dear students, hope you got the today's topic, that's about the molality. I'm repeating this again for you. First of all, molality can be defined as the number of moles of solid dissolved per kilogram of solvent. So first of all, I have taken the solvent to be A, solid to be B, the solution formed will be AB. So what's the molality? The number of moles of solid divided by the weight of solvent in kilograms. I have derived the number of moles of solute and the weight of solvent, and then I have put that thing all over here, to derive you the final formula for the molality. Now what's the unit of the molality? It's moles per kilogram, and then I have told you that molality is the more better and convenient method for measuring the concentration of solution than molarity. Why so? Because molarity is dependent on temperature. That is, if we increase the temperature, volume will expand, due to which the molarity will decrease. But on the other hand, molality is independent of temperature and is independent of volume. From where do I got to know? From the formula. If you carefully observe the formula, you will see that there is not the volume over here. That means molality has nothing to do with the volume of the solution. So molality is independent of volume of solution. Therefore, molality will not change on increase or decrease of temperature. So that's the molality. Now I'm going to solve some numericals for you. So let's talk about the first numerical. What first numerical is saying? The solubility of crystalline barium hydroxide. Crystalline stands for with water. It is like BaOH whole twice dot 8H2O. It's a crystalline barium hydroxide. The solubility of crystalline barium hydroxide in water is 5.6 grams per 100 gram of water. The question is, what is the molality of the solution? So my dear students, before attempting any numerical, I always ask you to classify your solute and the solvent. First of all, who is my solute? Like, who is my capital B? The solute is barium hydroxide dot 8H2O. That's my solute. Then who's my solvent? The solvent means capital A. Who's it? It's obviously water. That's H2O. So the given weight of solute is 5.6 grams in 100 gram of water. That is, the given weight of solute is 5.6 grams, and the given weight of solvent in question is WA. The given weight stands for W, solvent stands for S. So WA, it comes out to be 100 gram. So it comes out to be 100 gram. So let's calculate the number of moles of solute, because we need it in the formula of molality. So the number of moles of solute will be obviously the given weight of solute divided by molecular weight of solute. So what's the molecular weight of solute? Now, what's the atomic mass of barium? It comes out to be 137. 137 plus, what's the atomic mass of oxygen? 16. What's the atomic mass of hydrogen? It's 1. It comes out to be the weight of OH. But OH are 2 in number, so I have to multiply it with 2. What next? Plus. Now let's talk about the water. The atomic weight of hydrogen is 1, but hydrogen are 2 in number. The atomic weight of oxygen is 16 is in whole bracket, but water are total 8 in number, so I have to multiply the weight of one water molecule with 8. So this whole sum comes out to be 315. So that's the molecular mass of barium hydroxide dot 8 H2O, that comes out to be 315. So now let's use it in the number of moles. The number of moles, the given weight is 5.6 and the molecular weight comes out to be 315. Now 5.6 divided by 315, it comes out to be 0.018 mole. So my dear students, I have got the number of moles of solute, that's 0.018, and the weight of solvent is given in question, that's 100 grams. So now let's calculate the molality. The small m, molality comes out to be the number of moles of solute divided by weight of solvent, and if it's in gram, I have to multiply it with 1000. The number of moles of solute what we have calculated to be 0.018 divided by, what's the weight of solvent? It's 100 grams. So it comes out to be 100 into 1000. So it comes out to be 0.18 moles per kilogram. So my molality comes out to be 0.18 moles per kilogram. So please students, have a look of this numerical. So my dear students, let's move to the second numerical. Now what the second numerical is saying? It's saying that 250 centimeter cube of sulfuric acid 250 centimeter cube of sulfuric acid contains 24.5 gram of H2SO4. If the density of solution is 1.98, calculate the molality. So first of all, my dear students, who is my solute? Solute means B. Here solute is H2SO4, and who's the solvent? It's an aqueous solution. The acids are always aqueous solution, so solvent, my A, capital A, will be obviously water, that's H2O. So first of all, what's the given weight of solute over here? That's 24.5 gram. Given weight stands for capital W, is for solute, so it's WB. It comes out to be 24.5 grams. Now let's talk about the molecular mass of H2SO4. H2SO4. Now what's the atomic mass of hydrogen? It's 1. Now hydrogen are 2 in numbers, is 2. Plus, what's the atomic weight of sulfur? Is 32. And what's the atomic weight of oxygen? It's 16, but oxygen are 4 in number. So it comes out to be 98 grams. So the molecular mass of H2SO4 comes out to be 98 grams. Now let's talk about the number of moles of solute. The number of moles of solute is NB, that's WB divided by MB. So my MB was 98 grams. So it comes out to be, given weight is 24.5 divided by, what's my MB? Is my 98, and this valuation comes out to be 0.25. So now let's talk about our molality. Now what's the molality? Now molality comes out to be the number of moles of solute divided by weight of solvent, and if it's in gram, then into 1000. Now what's the number of moles of solute? It comes out to be obviously 0.25. 0.25 divided by, now we are blocked over here. First of all, we have to calculate the weight of solvent. So let's come back to question. I have to evaluate the weight of solvent from here that we need in the formula of the molality. So uh, the density of solution is given here. Density of solution is given, which is 1.98. So I'm writing density of solution, it is given to be 1.98 grams per ml. Now, what's the volume given in the solution? What's the volume of the solution given in the question? Sorry, that is 250 centimeter cube. It's 250 centimeter cube. I have already told you in the previous lecture also that centimeter cube and ml is the same thing. Now, density of solution will be equal to the mass of solution divided by volume of solution, which is equal to the 1.98. Now, here we have to calculate the mass of solution. The volume of solution is given to be 250 ml. I am putting it over here. It's 250 equal to the 1.98. So the mass of solution, it comes out to be 1.98 into 250. So this value comes out to be 495 grams. Now, what exactly the mass of solution is? The mass of solution is always equal to the weight of the solvent and the weight of the solute. I got the mass of solution to be 495. Now, weight of solvent, I have to evaluate that. I have to put it in the formula of molality. So, what's my WB? My WB have been given to be 24.5 grams. So, it comes out to be over here 24.5 grams. So, what I will do now? It's 495 minus 24.5 will give me the weight of solvent, and my weight of solvent exactly comes out to be 470.5 grams. So which I will put over here, that I got the weight of solvent, I'm putting it over here. Now it comes out to be, now molality is equal to the number of moles of solute divided by 470.5. Here is the weight of solvent, which I am putting it over here, into is in grams, so that's why we have to multiply it with 1000. Here my answer comes out to be 0.53 moles per kilogram. So my dear students, I got the molality. I hope you got this numerical. Please do have a look of this numerical, please. So I'm moving to my third numerical. That's the third one is a solution of ethanol in water. Here I got it, this ethanol. This ethanol is my solute in water, so water is my solvent. So what is solute? The solute, I always take it to be B, which is my ethanol. Ethanol. What's the molecular formula of ethanol? That's CH3 CH2 OH. So let us calculate the molecular weight of ethanol first, because in solute, so MB, it comes out to be, the atomic mass of carbon is 12. We are having 2 carbons, so 12 into 2, plus atomic mass of hydrogen is 1. We are having 3, 4, 5 and a 6 hydrogens, plus the atomic mass of oxygen is 16, and this comes out to be 46. So I got my molecular mass of solute. Now let's come back to question. A solution of ethanol in water is 1.6 molal. The molality of the solution is already given, it's 1.6. So question is, how many grams of ethanol are present in 500 gram of its solution? So the question is that we have to calculate the weight of solute. That means how many grams of ethanol are present in. Was the mass of whole solution given? It's 500. So that's my question. So first of all, I'm writing the formula for molality. The molality is equal to the number of moles of solute divided by the mass of solvent, and if it's in gram, then into 1000. Now molality is equal to the, what's the number of moles? That's WB divided by MB. Here is a WA, that's in grams, into 1000. So let's come to the mass of solution. Mass of solution. What exactly the mass of solution is? The WA, the weight of solvent, plus the weight of solute, it comes out to be 500. So my WA, it comes out to be is 500 minus WB. Obviously the sum of weights of solvent and solute will be the mass of solution. That's why I have taken WA plus WB will give me 500. So WA comes out to be 500 minus WB. So what next? I'm going to put this value over, I'm going to put this value over here. So let's come my molality. The molality is given to be 1.6. Now WB I have to evaluate. What's my MB? It's my 46. And what's my WA? That will be 500 minus WB into 1000, because it was 500 grams. My weight of solvent will be in the grams. So it comes out to be 1.6 into 46. It comes out to be 73.6 into 500 minus WB, and it comes out to be 1000 WB. So from here my WB finally comes out to be 34.27 grams. So my dear students, hopefully you got this numerical. This was also the easy one. Please do have a look of this numerical. So my dear students, I have done 3 numericals of the molality over here. If any student is having any doubt in these 3 numericals, please do leave your doubt in the comment section of this lecture. So I hope you all understood what's the meaning of molality and how it's different from molarity. I have given my phone number on the thumbnail of this lecture. If any student wants to book a paid one-to-one online class to clear doubts, contact me on my phone number. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.